Okay, so let's finish up a little bit where we left off. Just a quick overview here where we were. We've included a header file called arithmetic.h, and that's this file right here. So what was in it? There was a menu, and there were a couple functions, one for addition and subtraction. And we had some spaceholders here in comments in terms of doing multiplication, division, square root, and pow. So we're going to complete these jobs here, or these functions, for this header file to be complete. Obviously, we need to also make sure that the control function for this header file is also completed. And this is called the arithmetic operation function that is actually called from your main application right here based on the specific operation that you've picked up. So if you picked arithmetic operation because you have a menu here for the application that says that is what you wanted to do, then that will, when you call this function here, right, that belongs to this header file, what's going to happen is that this function gets executed, okay? And what it will do, it will in itself call an arithmetic menu function here that allows you to choose what operation you want specifically, okay? Addition, subtraction, we're going to add more. We want multiplication, division, and square root, and power. So let's go ahead and add these features right here in the menu, and then we will define these functions to be useful, to do something. So here we're going to add /t/t3. So we're going to have multiplication here. So a /n here. So as you can see, updating is much easier now, knowing where everything is. And this is how you can handle tons of lines of codes, knowing where everything is placed. So you logically need to break down your components, just like we started, to where your code is manageable for large projects of this nature. So we have division here. What else? We've decided to also have square root. So this will be square root of a number. And /t/t, we wanted to raise to a certain power. And that would be 6. We could call it a raise to a power. So /n, okay? So these will be the choices for the arithmetic calculator or subsystem calculator, right? The calculator overall will have, based on what the user wanted, arithmetic and trigonometry. But we have two subsystems. One is arithmetic and the other one is calculator. And the reason we're using this strategy is so we could reuse some of this code somewhere else. Okay? That will cut down on design in the future when we have a project that says, hey, you know, we need an arithmetic calculator in some other project. Oh yeah, I have a header file that I can reuse and include all of that code so we can get into development quicker and get a product out online quicker. So multiplication, we're going to follow the same structure we did for addition and subtraction. We're going to do the same with division. So basically I need a double. So you need to return something. Multiplication. So name the function what you want it to do. Have it take two variables, num1 and double num2, and then return the result. Return num1 times num2. Semicolon, close the curly brace. You're done with that one. It's that easy. Okay, division is a little trickier. You just have to make sure that maybe the denominator is not 0. Maybe you could have a loop that checks if the denominator is, if it's 0, it will keep asking you to re-enter that number. Okay? So that could be done here, or it could be done right here under the arithmetic operation. So we could simplify it and only go ahead and do a division here. All right? And we will get the logic right here under the arithmetic operation. Right? The logic of making sure the denominator is not 0. Right? So we're going to separate these jobs to make our functions do what they're supposed to be doing, period, nothing else. So in this case, go ahead and do a straight division, assuming you've already, before you call this function, verified that the denominator is not 0. We're going to see that in a minute. So in here, we're going to do division. And I'm going to stop at division. We'll come back to square root and pow to test our prototype. And let's assume we got up to division within sprint 2, right? And we're on our 3rd week under sprint 2. Sprint 0 typically is you're planning for the sprint. Sprint 1 will be what we did in the previous video. Now we're in sprint 2. We're in the 3rd set of 2 weeks, right? So 2 weeks per sprint, right? And that's where we are. So num1 double, that's if we're doing Scrum under Agile, right? Num3. Notice I didn't formalize the workflow or introduce you to Agile and Scrum yet. I'm just planting seeds here. When we get there, so these words will start making sense. So right now, I just simply need to divide these two. Divided by num2. And the only time I'm going to get here is, and this is where we're going to stop and make sure our decision making will support this. So it's going to be done here. First, let's go ahead and do, so if you picked 3, case 3. Now we've done addition. This will be multiplication. So again, see out. Enter num1 and num2. And then we're going to do cn. We'll just line it up a little bit. Num1, num2. And we're going to call multiplication here result equals multiplication. Let's test it out quickly and make sure that multiplication works. So what I can do now is either compile, you simply need to compile, or rebuild all, just to make sure everything is good. So I've got a little problem. Let me go to my division here. And it says num2 undeclared. Yes, because I have num3 here. Good. So let's go ahead and do this again. Rebuild all. And there you have it. Now let's go ahead and to the application itself and run from here. So we can actually compile and run. And we're going to pick arithmetic operation and see if we can do a multiplication. So 3, and I have a 2 space 6, and the result is 12. Okay, so if I do a 1 again, and if I do division, we shouldn't have anything yet, right? So notice that my result now, it returns some garbage. Okay, so I'm going to hit 3 here. And we're going to make sure that we handle the division right here. So that would be case 4. But now we need to be a little more. So let me just do a break here. And let's do a case 4. See out. And again, what I need you to do later on is to go back to enter num1 and num2 and do it each one separately. So that way you have better control over the interaction with the user. Right now, I am still at prototype stage. So I need to write code that I know will work, but it's much more efficient right now and quick, so I can get to my result. So cn num1, num2. Now, let's suppose num2 was 0. So we could do a while loop. While num2 is equals to 0, then go ahead and print an error and ask the user. So let me just put a curly brace here to close that while loop. And ask him to re-enter num2. So this is a good place to work that logic out. So cout can't divide by 0. Please re-enter make it clearer here, re-enter num2. And simply we're going to re-enter num2, and we're going to do cn num2. Now, notice if you enter anything then 0, you're out of the while loop. Otherwise, you'd be stuck in the while loop as long as you enter 0. Well, that's great. Well, now is the time to call the division and pass along num1, num2. And notice the only time I will use division as a function call is when I'm sure that num2 is not 0. Okay? And let's put a break here. And let's go ahead and test out the division for a minute. So let's go back, compile. I like to rebuild all just quickly. And then go back to the application here. We're going to run it from here. Okay? Compile and run. Okay? And we're going to do the arithmetic operation. We're going to do a division this time. I'm going to pick 4. And let's say I do 12 space 0. Can't divide by 0. Re-enter. So let's suppose I enter 0 again. So as you can see, it's catching the error. This is what we call data entry validation. Let's say I do a 1. So I know I'm dividing 12 by 1. And I get a 12. So that's good. Let's do it again. And this time I'm going to do 4 division again. And enter 12 and 3. And I get a 4. So it's dividing just fine. And everything works there. So let's continue on with the square root and raise to a certain power. So 3 exit. Okay. And let's go back to the arithmetic subsystem and finish up the square roots and so on. So again, for square root, you want to make sure that the value you enter under the radical is positive. So we'll definitely need to work out some logic. But, remember, I want to stay consistent with the style of coding that I'm doing. So I'm going to do a double square root. And it will take a double. This time it'll take single number, num. And this will simply return sqrt. Now you're going to say, wait a minute. Where did that function come from? They came from the CMath library, which I've included right here. Okay? And then you're going to say, can we make sure that whatever you enter is going to be positive? We're going to work that logic in the arithmetic operation. Since that's what I did with division, might as well stay consistent with your style of coding where you're going to work out the validation for the data. So here, simply go ahead and return this value. Okay? So that means go ahead and do square root of num, assuming that num was positive or equal to 0. So in case 5, this is where we're going to make sure, case 5, so cout, enter a positive value to find its square root. So we're helping the user understand they need to enter a positive value, but you can't guarantee that. So cn, and then this one you can assign to num1 here, which is a local variable within this function. and then go do a while loop again. While, and then again, you're going to verify that num1, if it is less than 0, then print an error message, right? So, and ask for reentry. So, cout can't complete this operation. Re-enter a positive number. Okay, so here you're going to do cn num1 again. Once you have a positive number, or 0, then you can go ahead and call square root. And result equal square root my function, and pass num1 to it, and then put a break. So as you can see, I worked out the logic right here when I chose that case, and passed along a value after I made sure that I tested its validity right here, which means I made my algorithm solution as simple as possible. So that means before I even did the square root, this was vetted. Okay, so I'm trying not to do the vetting here and complicate my algorithm, whatever it is that you're writing here. Now it just happens we're doing it SQRT. It's a very simple function call to a math library function, right? But what if you had your own custom, much more complicated story in here, and you needed to validate before you even get here, right? Be strategic in terms of where you want some of the work to be done, to simplify the actual critical areas where you might be doing some critical processing. Okay, we're going to do the same thing. Well, first of all, let's test it out. So every time we do something, let's just go ahead and rebuild all. Okay, and let's go to the actual application and compile and run. We're gonna pick. Now remember, the trig calculator isn't there yet. So if I do 2, nothing happens, right? So I'm going to do 1 arithmetic calculator. We're going to do square root. So I'm going to pick 5, and I'm going to put a negative value, -9. We know we're going to get an error. Can't complete this operation. Re-enter a positive number. Okay, I'm going to enter 0. Well, 0 is acceptable. Square root of 0 is 0. Let's do it again. 1. And I'm going to do square root again. So I'm going to pick 5. And let's do square root of 7. That's not a problem. Okay? So square root of 7, it gives you that value. And again, when you're ready to write the final version of this program, after you've tested it, after you've tested it at the local level and throughout the integration with the full application, or while you're doing all that, or right before you do all that, you can refine the output to round it up or whatever you need to do. But you have to be careful. You're going to have to check the non-functional requirements with you and your client. You have to agree as to what decimal point you can actually round off to, right? So in software engineering, you're going to learn about functional requirement versus non-functional requirements. So again, that would be a good place to, when you show this prototype to your client and say, by the way, we have a non-functional requirement here that will help the way the output comes out. Should we round it up to 2 decimal points or 1 decimal point? And again, you have the user knows in what domain they're using this application. Now, if it's to calculate chemical reactions, then they probably need to be at 3 decimal points. If it's measuring roughly some distances, then at 1 decimal point might be just fine. Again, it all depends where this is being used and who your client is and how they're using it. Okay, so you can customize it after that and how you want the output to be rounded up. Let's do an exit here. Let's continue on with the power. Okay, so let's go back to the arithmetic operation. So we still have 1 function to handle. as you can see now, we can pretty much predict what we want. So double, and this would be power. You can notice power is not a keyword as far as this function is concerned. SQRT is, POW is, so be careful. These are custom functions. They're not keywords. And this will take num1 and then double num2. And so that means num2 will be what is it you're raising it to. And this will simply return POW of num1, num2. So you're raising it. You're raising num1 to num2. So basically what you're doing num1 to the power of num2. Okay? So let's close the curly brace here. That's the end of that function. Do we need any validation? I don't think so. So this one will be straightforward. We're going to go down here and add case 6. This time I'm going to be a little more enter the base, what you want. Right? So cn, that would be num1. And then I'm going to enter cout, enter the exponent. And that would be num2. Now we can call the function and then make sure that you store it in result equal, and that would be power, pass num1 and num2 here, my local variables right here. Make sure you put a break here so you can get out of this case. All right, well, let's test it out. So at this stage, I'm going to go ahead and do a rebuild all. Okay, so I have no issues. Let's go ahead and run our program. And we're going to be testing out the last feature for this calculator. So compile and run. So 1, arithmetic calculator. We're going to do 6 raised to a certain power. And let's say we have 2 and the exponent is 2. So the result is 4. Okay, so that looks good. Let's raise it to 0, okay? We know that should give us a 1, so let's go ahead and do a 6. And let's do a base of 2 and 0 for the exponent. And that gives us a 1. So anything raised to the power of 0 gives you a 1, okay? So we now know this works. So all of these features that we wanted, 1 through 6, each one was a task within this group. And each task takes time to produce. So when you're planning, during the planning phase, you need to evaluate how long these tasks are going to take, which ones are a priority. And you could see that addition and subtraction were a priority for me for the purpose of a rapid development. So I can actually have something at the end of a sprint to show to my client and say, we're on the right track. Is this what you want in terms of interfaces? We will handle the division, square root, and multiplication and raised to a power for the next sprint. And then they have full confidence in your work. And then you can continue on that way. This is typically how modern software engineering works. You're getting your client as being a stakeholder in various design phases, especially when you're cycling through different versions, just to keep them in the loop. So this is not what we call a waterfall method. This is more of an iterative method in terms of design. Okay, so every time. So notice here, my next sprints are going to be, we're going to be handling the now. Obviously, if I had more manpower, I could have had people already working on the trig calculator. And these two would have come in at the same time. Now, that is called project management. That's a totally different aspect of managing projects, because then you're allocating based on resources that you have. You're looking at manpower, you're looking at cost, you're looking at a whole bunch of other things. So above and beyond just workflow, which you would do with Agile and Scrum, you're going to have to think about a little higher in terms of project management. And yes, the project management will be based on the scope of your project. However, you could actually schedule some of these sprints in parallel if you have various groups. Okay? So some of the work, depending on where you want to schedule them, could happen at the same time, maybe a little bit off until you get some results from one group, etc., etc. So it all depends on what you're doing. So for the next video, we're going to do the trig part, okay? And then time permitting, we'll do some cleaning. Actually, why not do some cleaning right now? So every time, which means clean up the screen. Remember when I run this? Let's run it here for a second. So if you can do something, you can add value to something, do it. Don't waste time. Notice here, if I choose arithmetic calculator, wouldn't it be nice to clear up the this part right here, calculator choices. Clean it up and just have this on the screen. Okay? So let's say we choose 9. That doesn't exist. Invalid operation. I did that on purpose to get me out. And I'm going to do 3 to get out. Okay? Wouldn't it be nice if I could clear the screen right here? So remember, you could clear the screen right here. So remember, we could do a system CLS or clear, depending on, I believe it's CLS in DOS. Let's see how that works. So compile. This one, just compile and run. You're doing this in the main application. And let's say we pick 1. Notice it didn't do it. That's because I'm not out of there yet. Let's see. It hasn't called. It should do this right after I call menu. So let me just Control C. So it's a matter of where you want to place this. Let me cut this and do it right after I call the menu, right here. That clears the screen. That makes more sense. All right, so let's compile and run. So this will make the output less busy and much more readable. So compile and run, and there you go. So let's say I pick the arithmetic calculator this time. Notice it clears up the screen nicely for me. So let's say I pick addition. We could also clear the screen here once you pick addition and what have you. 1 and space 2, and then you're back to here. So probably it's a good idea. Notice here, when we come back, calculator choices is back here, so we need to clear the screen at the end as well. So maybe where I had it was a pretty good place as well. So you might have it in 2 places. Yep, you could do that. So let me just pick a 3 here. And let's just put it in here. Oops, Command V. So just so we can clear the screen at the beginning and at the end. All right, so let's try it again. Compile and run. So arithmetic operation. So I'm going to pick 1 addition, 1 and 2. But notice here it went too fast, so I couldn't hold the screen. So we're going to hold the screen now. Okay, and I'm going to do 3 exit. And this press any key to continue, I am going to do it right. So I'm going to cut this. So it's just a little massaging here and there, okay? Voila. Okay? And let's compile this and run. Let's see how that works. Okay? So let's pick the arithmetic calculator. Let's do an addition. 1 and 2. Notice it's going to hold the screen from me. Press any key to continue. Perfect. Right? This is much better. Okay? Now your client will be a lot more comfortable while you're presenting your demo. So clean it up. if you have time to do something like that. If it's a huge task, then you might want to adjust your tasks for the next sprint to include that. Remember, this is when you're doing Agile and Scrum, it's in situations like this where some of the requirements shifts on you, either from the client or some of the requirements internally within the design itself. Your models may shift a little bit, which we had, right? Especially in the include use case, we shifted the input out of that, just made the output as part of the include use case, right? So that was a design issue. Okay. All right. So for the next video or the next lesson, we will concentrate on the trig calculator.